Hi everyone, I am R.V. Kiran, Assistant Professor, Department of Mechanical Engineering. Today, in this video lecture, I am going to explain the manufacturing methods of fiber reinforced composites. We have already discussed about some of the manufacturing methods, and in this video, I am going to explain two major manufacturing methods of FRC. First one is the autoclave method and second one is the prepreg method. So this is my 14th lecture in the advanced materials subject series. So these are the different types of manufacturing methods that are used to manufacture the fiber reinforced composites. So first one is the hand layup, spray layup, filament winding, pultrusion, resin transfer molding, that is shortly named as RTM, autoclave method, and different types of molding methods. So in this video lecture we are discussing about the autoclave method and second one is the prepreg method, so which is one of the molding methods. So these are the two types of methods we are going to explain in this video lecture. So in the previous lectures we have discussed about the hand layup, spray layup, filament winding, pultrusion and RTM. So this autoclave method is very far different from these previous methods, and also some more invertible structures have been imparted in this manufacturing method. So let's see what is the different types of characteristics and what are the process of this autoclave method, which we are going to describe in this video. So first of all, we are going to explain the autoclave method. So this is also known as autoclave curing method also. So this is the second method. So autoclave curing method is a method in which a part or mold can be by one of the open molding methods. So these can be imparted in the regular die, that is a split die, and these can be molded by one of the open molding methods, that is by using a split die method, and this is cured by a subsequent application of vacuum and heat and inert gas pressure. So by applying the heat and inert gas pressure in this low vacuum space, we are going to cure this autoclave molded part, and the molded part is first placed into a plastic bag from which air is exhausted by a vacuum pump. So this is type of a method which we get a cycle pump and pushed the air into a bubble. So మనం ఎప్పుడైతే ఈ సైకిల్ పంప్ నుంచి ఒక పెద్ద బెలూన్ కానీ ఇట్లాంటివి ఊతుంటాం కదండి, సో ఆ టైప్ ఆఫ్ మెథడ్ అనమాట ఆటోక్లేవ్ మెథడ్. మనకేంటంటే ఈ ముడుచుకుపోయినప్పుడు చాలా తక్కువ స్పేస్ ఆక్యుపై చేస్తుంది, కానీ ఎప్పుడైతే మనం ఈ ఇనర్ట్ గ్యాస్ ద్వారా హీట్ అనేది కానీ ఇనర్ట్ గ్యాస్ ప్రెషర్ కానీ ఎప్పుడైతే రెగ్యులేట్ చేస్తూ ఉంటామో ఆ గ్యాస్ మొత్తం కూడా పెద్దదైపోయి ఆ వాల్యూమ్ని ఎక్స్పాండ్ చేస్తూ ఉంటుంది అనమాట. సో దిస్ ఈస్ డన్ బై ది from which air is exhausted by a vacuum pump, and this operation removes the air inclusions and volatile products from the molded part. So this can also remove the air inclusions, which is a major part. So the air is the subject here, and the volatile products also removed from the molded part. Then heat and inert gas pressure are applied in the autoclave by causing and curing the densification of the material. So then the heat and inert gas pressure are applied in the autoclave, causing the curing and densification of the material only. So we have already discussed about the flowing of inert gas pressure and the heat into the molded part, which is the vacuum region. So also autoclave curing enables the fabrication of consistent homogeneous materials also. So this enables the producing of some homogeneous materials such as fiber wood. So these are also homogeneous materials, and this method is relatively somewhat expensive to the other parts, which means that there is some complex parts which we can assemble in this method. So this method is relatively expensive and is used for the manufacturing high quality aerospace products. So these are highly used in the manufacturing of aerospace products. So these are the basic introduction for the autoclave method. So this is the line diagram of the autoclave method. So this autoclave method is also known as a closed vessel method, which is round or cylindrical, in which the processes occur under simultaneous application of high temperature and pressure. So this is the line diagram. There you can see the bagging film, which is compressed by the high autoclave process. So this high autoclave pressure can be immerse the bagging film into the low vacuum pressure, and next part is the sealing strip. So by reducing this air tight vacuum, you can seal the strip on one side, and there is a prepreg and breather on the inside part of the area, and there is the tool which is the molded part of the region, and by the vacuum pump the waste gas or waste air can be removed from the vacuum pump, which is on the right side of the autoclave image. So you can see it in the image also, picture also. So a vacuum pump is created on the right side, which the waste air or air inclusions can be removed from that part only. So this is the basic process which we occurred which we are used in the autoclave process. So there you can define the high autoclave pressure or temperature, which is on the upper part of the bagging film, and this bagging film is somewhat the thickness than the other materials, which is manufactured by fiber reinforced composites. By using long fibers we can manufacture this bagging film, and this is somewhat a replica to the balloons. So we can see the balloons outside, somewhat thickness balloons. So this bagging film is similarly applicable to that material also, but the balloons are made of the rubber, which have high elastic nature than the fibers. Next one is the process of generating this autoclave method. So there are two pictures there. So first one is the picture, already we have seen that picture in the previous slide, that is the high autoclave pressure and a thin bagging film, and a sealing strip is on the one side of the autoclave, and next one on the interior of the bagging film there is a prepreg and a breather, and the tool is inserted downward on the bagging film, and a vacuum pump is created on the other end of the sealing strip, that is to remove the air inclusions, extra inclusions of the air. So this is the basic process. Second one is the autoclave process to make a laminated composites. So we have already discussed about the laminates in the previous lectures, that is on the introduction lectures of the advanced materials. So lamina means layer by layer. So creating a strip by putting a layer by layer on the fiber composites. So we are placing one layer on the other layer and we are treating it as a sandwich panels. So but the difference between the sandwich panels and the laminates are, so in the sandwich panels the thickness of the materials can be varied, but in the laminate the thickness can be not be varied. That is, the properties can be varied, or the materials used can be varied in different compositions. So here you can see the different types of compositions used in these layers. So, and these are also different types of prepregs of different orientations. So we can use the different orientations here. Stacked. So stacked means placed to form a laminated composites. So different orientations means different types of layers have been used in this type of orientation. So there we can see the cross section view of the laminated composites. So all the fibers here are parallel to each other, but the direction is different. So you can see it in the indication symbols, that is A, B, X and Y. So in the first laminate, that is the A type of section, that is 0 degrees, and in the second section B, that is on 90 degrees. So the short fibers are which is 90 degrees to the axis, and third one is the X axis, that is minus 45 degrees, and last one is the y-axis, that is of the plus 45 degrees, so that is of positive 45 degrees. So we are turning the fibers into different modules of directions. In the first 4 lamina we are doing this type of single laminate in the single layer, so A, B, X and Y. Then again we are repeating the same amount of laminates in the second cycle also, that is in the bottom part also. So total there are 8 types of laminate composites in this section, in this picture. So first 4 is the ABXY, and therefore there we are repeating the same amount of different variations in the next cycle also. So this is one of the example for the autoclave, one of the autoclave material. So going to the characteristics of the autoclave method. So it is very high quality product. So compared to the other process, we get a very high quality product from the autoclave method, because we are using different types of compositions here, so to gain the quality. So generally prepregs are morely used in the autoclave method. So what are the prepregs? So prepregs can be discussed in the later slides. There we can see the detailed classification or detailed explanation of the prepregs. Next one is the chopped fibers with resins can also be used. Here in the laminates we are using only the long fiber, but chopped fibers with resins can also be used to define the volume of the vacuum. Next, hybrid composites can be produced. So different types of hybrid materials can be used, and hybrid composites can be used in the lamina reinforcement composites. Next, high fiber volume fractions can be also be obtained. So different types of volume fractions can also be obtained by this high amount of fiber. By using high amount of fiber in the reinforcement, we can obtain high fiber volume fractions. And last one is the simultaneous application of high temperature and pressure. So first of all, in this process, this is the main object by applying the high temperature and pressure. So this helps in consolidating the laminate. First one is the consolidating the laminate, and second one is the removing the entrapped air. Third one is the curing the polymer matrix. So by using these 3 conditions, we can easily apply the high amount of temperature and pressure. So by applying high amount of temperature and pressure, we can easily design the complex shapes where we can use in the different modules. So these are the different types of characteristics which we can obtain in the autoclave method. So by consolidating the laminate, so by using the proper administration in the laminate composite, we can define the high temperature by also removing the entrapped air. Entrapped air means waste air, that is waste air inclusions. We can entrap the, remove the entrapped air. Last one is the curing the polymer మ్యాట్రిక్స్. సో క్యూరింగ్ మీన్స్ ఆరబెట్టుకోవడం. సో ఎప్పుడైతే ఆరిపోద్దో పూర్తిగా కూడా ఒక సాలిడ్ ఫామ్ లాగా అవుతుందో, సో ఈ పాలిమర్ మ్యాట్రిక్స్ అనేది కూడా మనకి హై టెంపరేచర్స్లో ప్రెషర్స్లో యూజ్ చేసుకోవచ్చు. సో దిస్ ఈజ్ అబౌట్ ది ఆటోక్లేవ్ మెథడ్ ప్రాసెస్. So then we can go to the second method, which is the prepreg method. So next method is the prepreg method, prepreg manufacturing method. So this name prepreg is the industry term for continuous fiber reinforcement. So when we are using the term continuous fiber reinforcement in the industries, we are using this prepreg. So this is already a manufactured part, so that is known as the composite industry term, which is used for continuous fiber reinforcement. So with pre-impregnated with a polymer resin that is only partially cured, so that is a fibers pre-impregnated with a polymer resin, we can be partially cured in these prepregs, and these prepregs is delivered in tape form to the manufacturer, who then molds and fully cures the product without having to add any type of resin. So this is a pre-prepared strip of thin volume. So this is delivered in the tape form. So these are usually delivered in the thick tape forms, where we can use it as artificial method also. So it is a hybrid method. So when we have to use it in the suddenly, we are going to use it, and these molds and fully cures the products without having to add any type of resin. So no amount of resin has been used in the methods of prepreg. So this is the composite form mostly used, widely used for structural applications. So these are highly used in the structural applications, that is in the lamina composites or concrete layers or different methods. So these are highly used for the structural applications. So there you can see the prepreg, one of the tape form of prepreg. So there you can see the different types of layers. So here we have taken three types of layers. So first one is the polyethylene film, which is seen in the dark color, dark black color, and second one is the unidirectional composite. So we are using the composite in the middle lamina, so that is in the dark and vacuum space. And third one is the silicon release paper. Third strip is the silicon release paper. So these are the three types of lamina used in the prepreg. So this is one of the examples. Not all the material has been used in this form only. This is one of the example only. So by applying the silicon release paper in the unidirectional composite, we have obtained a thin layer structure called as polyethylene film, which is generally dark in color. So this polyethylene film is generally darkish in color due to its structural composite. So here you can see the process of prepreg. From the right side you can see the different parts here, which first one is the spooled fiber, that is the wounded fiber. So there contains two types of direction, one on the upper side and one on the lower side. You can see the on different colors, blue and greenish color. Next one is the waste release papers and rollers obtained here. So when obtaining a roller, we can cut this by the doctor blade, that is a thin blade, and the release paper has been stripped into the sandwich panel. So first of all, manufacturing begins by collimating a series of spool wounded continuous fiber toes. So fiber toes has been attached in this. So by wounding a spool wounded continuous fiber toes, we are starting this manufacturing process, and these toes are then sandwiched and pressed between the sheets of release and carrier paper. So this carrier paper has been indicated in the green color here, and next it is seen in the final pregnated paper. You can see it in the yellowish color also, and this carrier paper using heated rollers. So the rollers have been obtained at such amount of temperature here. So some amount of temperature has been widely used in these rollers also, that is called as calendering. So these heated rollers can be called as the calendering also, and the release paper sheet has been coated with a thin film of heated resin solution to provide for it thorough impregnation of the fiber. So these resin have been used as the layered part in the type of rollers and the thin films section also, which is spool wounded fiber. So these fibers have been attached in the interlink bonding of these laminates. So there are different types of laminates here, which you can see in the color combination. First one is the green one, and second one is the blue color one, and third one is the yellowish one. So there are three types of layers here, and these wounded fibers have been impregnated in between these layers. Next, the final prepreg product is a thin tape consisting of continuous and aligned fibers embedded in a partially cured resin. So these can be cured in the partially cured resin also. So these are the basic process. So there you can see the different parts of the prepreg model. So first main one is the spooled fiber, which is rolled different types of fibers, and next one is the carrier paper, which is seen in the green color, which rotates on the clockwise direction. And next one is the spooled prepreg, which is seen in the bluish color, which rotates also on the clockwise direction. Third one is the release paper, which is seen in the blue color, that is rotating on the anti-clockwise direction. Here you can see two different types of heated calendar rolls, that is known as calendering. So one is rotating on the upper one is rotating on the anti-clockwise direction, and lower one is rotating on the clockwise direction. And later we can see the waste release paper. On the top of it we can see the release paper and a hopper containing heated resin. So these resin have been seen in the hopper containing heated resin, and a doctor blade is used to cut the strip where we can define the length of the prepreg strip. So this is the basic process of the prepreg module. Next, going to the characteristics of the prepreg, These prepregs can be stored at 0 degrees centigrade up to 30 degrees Fahrenheit or lower because matrix undergoes curing reactions at room temperature only. So we are storing it at 0 degrees centigrade. Also, the time in use at room temperature must be minimized. So because room temperature gets up to 25 to 30 degrees in the winter season and 40 to 45 degrees in the summer season, so we can use the less amount of time in the room temperature also. This lifetime of the prepregs is about 6 months if properly handled. So if we properly use the prepregs, we can use it for approximately up to 6 months. Both thermoplastic and thermosetting resins have been utilized. So majorly used resins are carbon, glass and aramid fibers are the mainly used reinforcements. So the commonly used reinforcements are carbon, glass and aramid fibers. Next, actual fabrication begins with the layup process only, which is partially impregnating of layer by layer with a lamina composite. Normally, a number of plies are laid up to provide the desired thickness. So, number of layers can be used on the different types of thickness layers, and thickness have been provided with the desired thickness only. The layup can be by hand or can be used in the automated process also. So we can use it in the manual process as well as we can use it in the automated process also. Then these epoxies have been easily obtained from these types of process. So the epoxy resins have been used in the different types of conditions here, and different types of layups can be obtained by these method. So this is the basic characteristics, and we have some more characteristics on the next slide. So depending upon the manufacturing, it is prepared for packaging by winding onto a cardboard core. So on a cardboard core roller, we can use winding it on a packaging. So we have already studied that prepregs is obtained in a thick strip process in the market. Market, so we have obtained it in only in the thin strip only. There we can use by winding onto a cardboard core only. Then typical tape thickness ranges between the 0.08 mm to 0.25 mm. So this is very thin tape, which is approximately from 0.08 to 0.25 mm. Then these tape widths range between 25 and 1525 mm. So these tape widths can be ranges between the 25 and 1525 mm and only, and the resin content lies between the 35 and 45 percentage of volume. So up to half of the amount of volume we can use the resin content in the prepregs, and some more ingredients can be used with as the reinforcements. So these are basic characteristics of the prepreg module used in this condition. So these are the different types of characteristics we are used. So mainly we are using it as the pre-ordered module only, which is obtained in the thin strip module. So this prepreg can be used it in the autoclave method also, where it is used as intermediate part only. There we can obtain different types of high pressure and temperature modules. So by obtaining different types of properties, there we can utilize these number of components into different types of characteristics. And thank you.